Question show time. Your questions, my answers, as always, wherever you are, across my channel. Question pops in your brain. Write it down. I'll gather them up and I'll answer them here. I put a bunch of seeds right behind me there, so we'll see if the birds take the bait and show up. Hummingbirds giving me the evil eye, so we'll see. Now, people are always asking me what books I'm reading, and I've sort of mentioned a bunch, but I thought I'd try to more regularly tell you what I'm reading. So first, I'm reading a couple of fiction books right now. One is I finally started the Culture series, which is, of course, the Ian M. Banks books. Elon Musk named the drone ships after them, after some of the spaceships in the Culture series. So I read the first one, Consider Plebius. It was good. It was not what I was expecting, but I did really enjoy it, and I'm looking forward to reading the rest of them. And then the other one that I'm reading is I'm rereading the Foundation series by Isaac Asimov, which is one of my favorite series of books. So reading the second one right now, Foundation and Empire, and it's interesting to see which parts of it hold up and which parts of it don't. So, but if you have some book series that you think I should read, put them in the comments below. I would love to dig into it. I'm sort of trying to put a lot more emphasis on reading these days, setting aside time to do it. So I will soon have lots of need for more books. So let me know what you like. Finally, I've got two non-fiction books that I just read. So one is called Beyond the Known by Andrew Rader, and he works at SpaceX. Worked on the Dragon program, I think. And he is going to be, I don't know if it's in frame, he's going to be showing up on the channel in the near future for one of the live QAs. So get your questions ready for Andrew. And his book was great. I really enjoyed it. I don't think I've run across a book that has like that level of density of stuff I just didn't know. And it's all just about exploration of the past and then how it leads into the future. And it was the history stuff that I really enjoyed. The other one is Lewis Dartnell's Origins, and it really tells about how the history of humanity is connected to the geology of planet Earth. And again, tons of stuff that I didn't know at all about. Not so much about space exploration, but really fascinating book. But both Andrew and Lewis are going to be participating in upcoming question shows, and they will be guests on some of the shows, so stay tuned. But thanks to both of them for sending along their books, and I can't wait to have them show up and answer your questions. All right, speaking of questions, let's get into it. Building with Todd. Hey Fraser, is it possible to build a steam-powered rocket powerful enough to reach orbit? Just watched Rocket Man about the gentleman that built a homemade steam-powered rocket to see the Earth curvature himself, and it sparked my imagination. Thanks for sharing, and as always, keep building. A rocket that uses a coal-powered or steam engine wouldn't be able to fire long enough to be able to reach orbit. But when you think about what, say, the space shuttle uses, right? The space shuttle's main engine uses liquid oxygen and hydrogen, which are the hydrogen is burned with oxygen, merged together, and they produce water vapor, which is coming out at incredibly high velocities. So water vapor works as a perfectly acceptable escape gas from your rocket. It's just that you need a way to get it at those high velocities, which is why they use liquid hydrogen and liquid oxygen to achieve it. There's also been plans to use various kinds of nuclear rockets. So you run a nuclear reactor, get it very hot, mix it with hydrogen, mix it with oxygen, and you produce water vapor as your exhaust gas, and you can again achieve the kinds of velocities that you require. The other idea that I really love is there's a couple of companies that are working on this idea of a steam-powered thruster for space. So once you're already out in space, you've got some kind of spacecraft that goes to an asteroid, mines a little bit of the water out of it, and then superheats that water, and then uses that as a propellant, as a thruster to be able to move itself around. And a spacecraft that could do that could go just from asteroid to asteroid, gather up all the water that it needs, and really travel forever without having to be refueled from Earth. So the future may very well be steam-powered rockets, which is such a great idea. So thanks for sending that in. And I should do a video on it. I will. I'll do a video on it. Hey Fraser, I have a question. Have any space probes ever been destroyed or damaged by running into an asteroid or comet unexpectedly? A cosmic car crash. So when a spacecraft runs into a solid surface, the joke is you call that lithobraking. And we've seen this happen a bunch of times, and generally it's because, you know, with the moon or Mars, it's for whatever reason, your retro rockets didn't fire, the timing was wrong, you were coming in too fast, the Indian Vikram lander lithobraked, Israel's Bereshit lander lithobraked into the moon. Many spacecraft have smashed themselves into Mars. They've smashed themselves into Venus. These are difficult places to reach. But not that I can think of an asteroid or a comet. Generally, they're very careful about the way that they approach asteroids and comets. They go into orbit, and then they carefully and slowly lower their altitude until they are going to land on the object or collect a sample or whatever it is that they're going to do. Now, various impactors have been crashed into comets on purpose and asteroids on purpose to excavate a chunk of what they're made out of, be able to look at the material as it flies out into space and be able to use that to figure out what's under the surface. And that has been done several times. And then I think about the Near spacecraft that landed on asteroid Eros. It wasn't planned to land on Eros, but in the end, when the mission was over, they lowered it down, tried to get as many pictures as they could moments before it settled gently, lithobraked onto the surface of Eros, and it's still there. So not exactly a comet or an asteroid, but spacecraft have smashed into the moon, Mars, Venus, many other places unintentionally, and it's a very likely occurrence because space is hard. Ryan Surtick. Hey Fraser, you said drop a question anywhere, so here I am doing just that. I was looking at a video comparing sizes of objects in the universe, which always blows my mind. UY Scuti came up as the biggest known star, and I began to wonder how much I would weigh on the surface of it. After some searching, it seemed that I would weigh less on the surface of UY Scuti than on the Earth. Is that true? It seems strange, but does it have something to do with the relationship of size and gravity to the center of the object's mass? Thanks in advance. Yeah, you're exactly right. If the star UY Scuti is like gigantic, it would go out beyond the orbit of Saturn if it was in the solar system. And so you would think that a star that big would have an incredible amount of gravity. And it does. It has an enormous gravity well because it is has a tremendous amount of mass. And if you try to escape from that star, you know, it's going to be multiple times the mass of the sun. If you tried to escape from it, it would be very difficult to do. But because the size of it is so big, the density across the entire star is actually very low. And I did the math, and it is a fraction of 1% of the gravity that you would experience on Earth. Now, of course, you couldn't jump up and down away from it because it's a star, but you wouldn't experience very much gravity. While, say, on the sun, you would experience many times the gravity that you experience on the surface of the Earth. And that is just because the sun is smaller and denser compared to one of these big red giant stars that are puffed way out. And whenever you think about, I mean, this comes up with planets as well. When you think about super Earths, and they have 10 times the mass of the Earth, but as long as they're, say, twice the size of the Earth, I think, then the gravity on the surface kind of works out about the same, or maybe it's like twice the gravity of the Earth. But the point is that just because a planet has double the mass of the Earth, as long as it's not the same size as the Earth, then the gravity isn't going to be double. It's all the relationship comes down to the size and the radius, the mass, the density. You got to take all those into account to figure out what the gravity is going to be on the surface of that world or star. Inspired art dolls. Do you think that we will ever be able to have the technology to safely send a human to the surface of Venus? I don't like to say never, but it's a really terrible place, right? The two big things are that heat of 460 plus Celsius, hot enough to melt, I don't know, some other metal. I've gone through cadmium, zinc, I'm not going to say lead, some other tin, hot enough to melt tin. So that temperature, we don't really have electronics that can handle that kind of temperature. We don't have air conditioners that can run for a very long time to keep that cool. So the heat of that planet is going to be getting in, and eventually it will cook you like you're in an oven. And then there's the pressure, right? The 93 times, 95 times the pressure of the Earth down at the surface of Venus that will be absolutely crushing. It's the same as being a kilometer down on the ocean of Earth. So again, just too much density, too much pressure. The atmosphere is made of carbon dioxide, which you can't breathe, and it rains sulfuric acid. So all of these conspire together to make Venus just a really horrible place. And it would require really kind of magical engineering for us to be able to build a base down at the surface of Venus and be able to have humans be down there and survive. And if anything went wrong, right, the pressure would crush the habitat, the temperatures would be constantly trying to cook it until everyone inside was roasted. So I can't imagine it's going to be a thing that we'll be able to do until there are incredible new technological advances hundreds, maybe thousands of years from now. And of course, the other option is to fix it. Just make Venus better, right? Terraform it. But again, that's complicated as well. So it will most likely be that the surface of Venus is going to be a place that we can just never get to. As much as that just sucks. Pedro Furia. NASA always plans, but it doesn't get things done. Future exploration in 2900, lol. I always wonder, when a person writes lol, do you say lol? Should you say laugh out loud, or should you just laugh out loud? I don't know. I'm Rashid. What about radiation? Venus lacks a planetary magnetic field, so humans will find it hard to survive among the clouds of Venus. Venus doesn't have a magnetic field like the Earth does. It has no plate tectonics. We've talked about this before, that at some point in the either recent or distant past, the entire surface of Venus just went and just turned itself inside out, and that's its version of plate tectonics. Is, every few 100 million years, the planet just turns itself inside out. Sucks to be on the surface, and so you don't get that, and you just don't get that planetary magnetosphere the way we have here on Earth. But even when you're up in the cloud tops of Venus, you've got enough atmosphere above you that, in fact, your protection from solar radiation is about the same as if you're on the Earth. So actually, as long as you don't terraform Venus and remove that really thick protective atmosphere, it's not that bad from a radiation standpoint to be up in the cloud tops of Venus. A.B. Scott and Flower. Fraser, please consider doing 2-hour specials when you have interesting guests. Maybe the last half hour taking questions. 1 hour is consistently and clearly far too little time. That's a tough one. Like, on the one hand, of course, I need to respect the time of the guests, right? I'm talking to the director of NIAC. We're talking to people, project managers at James Webb who are busy building James Webb. So I need to respect their time. And I already feel kind of guilty having them come and hang out and answer questions for an hour. I try to make it as entertaining for them as possible, but at the same time, they're busy. So I don't know whether I could stretch things out to a 2-hour. I mean, I know that like Joe Rogan does long interviews like that, and maybe as we get more followers, we will. But I'd love to hear your thoughts, right? Are the live stream interviews too long, too short? Do you not even watch them? Do you only listen to them on the podcast? I would love to know what your take is on them. It blows my mind that people all want to even sit and watch that. And maybe that's just my imposter syndrome talking, that you want to like listen to me talk for an hour, but or hear in a question show for half an hour. But I'd love to know what kind of content. I'm always trying to figure out what is the kind of content that just fills in the whole puzzle for all of you. So please always give me the feedback. You, especially the fans, the people who like the work that we do, you're the best people to be able to provide us feedback to know what we should be doing. So don't ever hesitate. If you think we can do something better, please let me know. S.E. Sander. Fraser Cain, sir, please save your shoutouts until the end of the video. It totally kills the momentum of the entire plot line when you interject with promotional shoutouts like that. Other than that, though, I have to say this is another great video, as usual. Just some friendly advice. Take care and thank you. So we have ourselves a bit of a catch-22 here, which is that if it wasn't for the patrons, then the videos wouldn't exist at all, and I wouldn't be doing this job. I would be, I don't know, working at a grocery store, maybe being a logger. My degree is in computer science, so maybe I'd be like a computer program. I'd be working for Facebook or something. I don't know. What job should I have? So I really feel, and then the other thing is that I try not to, like, I turn down sponsorship offers. I have turned them all down. So you won't see, or you have not seen sponsorships in any of the videos that I've done fairly recently. There's still ads that run from YouTube, but I don't take on any additional sponsorships. I don't put a lot of ads in the videos. I just put the one and at the beginning, and that's it. So I feel like that's the right balance. All you have to endure is for me to say some nice things about a few people that help make those videos possible in the first place. And I feel like that's fair. So thank you to all the patrons. Again, I would be doing some other job if it wasn't for you. So thank you. And Chad, of course, whose salary I pay, thanks you. Matt and Evan and David Dickinson and all of the other writers who work over on Universe Today. We couldn't do this without your support, so thank you. I just snuck another one in there. João de Carvalho. I suppose that if a submersible is able to float at 1 kilometer underwater, a sturdy probe could float near the surface without the need for a balloon. Even though the pressure on Venus down at the surface is, we talk about this before, 93 times the surface pressure of Earth, it is the equivalent of being 1 kilometer down below the ocean. If you drop a rock into the ocean, it will gladly sink down to 1 kilometer and keep going all the way down to the bottom of the bottom, the deepest trench on the ocean. And so you'll never get a place where a probe will float around in the atmosphere of Venus, even if you're right down at the surface. You're always going to need some kind of lifting gas that is less dense, lighter than the atmosphere around it for it to float up. Jim Lockwood. I know you always provide links to the papers that you talk about, but where do you find the scientific papers at? Is there some kind of journal that you subscribe to or an online repository? Keep in mind that I've been doing this job for a long time, and so I've built up sources for decades. And a lot of material that I get is recommended to me by sources who reach out to me and say, hey, Fraser, here's a new piece of research that we've done. Are you interested in it? That said, there are public sources for almost every piece of news that you're ever going to see if you're willing to trace it back to the source. Now, at Universe Today, which I have control over, of course, we make it very clear what the source of the news is. So we try to put the source of every story down at the bottom. And so if you're interested on where we got the news from, you can trace it back to the source. Sometimes that's a press release. Sometimes that is a journal or some other piece of information. And even when it's a press release, so say a university will report on some new piece of news, they're usually basing that on research that's being done within the university. And so there's going to be some underlying journal. Now, my favorite place to find papers is this place called Archive, RXIV, and specifically the AstroPH, the astrophysics subsection of that. And this is the prepress. So a lot of the researchers, as they're working on new pieces of research, they'll put their papers into Archive, and there are usually like dozens, if not 100 every single day. And so every day I look through the entire list, look for any story that's kind of interesting, and then I set them aside and then consider whether or not I want to report on them. And a lot of the stuff that I talk about in this come from that. But there are also astrophysics journals, there are engineering journals, NASA produces a ton of scientific papers. So it's like this puzzle that you build up bit by bit. And the easy way to start is to just set yourself the challenge when you see a piece of news to go, where does this come from? And you'll see these keywords. So in the story, someone will mention that this researcher and that researcher published their new work in the journal Nature. Well, there's the source, right? It's a scientific paper that was published in the journal Nature. And you can find the issue, although Nature makes it difficult for regular people to be able to get access to the papers themselves. But a lot of the times, if you search for the title of the paper, you can find some other version, like maybe the pre-press version of it, or some other time that it was published in another paper earlier, or another journal earlier. And so generally you can kind of trace every story back to its roots. And that's my job, right? My job is to look at every story that is happening all day and go, where did you get that? Where did that come from? What's the source? And so if I don't already know what the source is, then I add it to my list of sources. And you should see my list of sources. It is hundreds, thousands of different places that I look every single day for 10, 20 interesting things that are breaking. And then I take those and I provide them as stories to the writers on Universe Today and say, we should report on this and we should report on that. And of course, we try to make sure that always you can find out where we're getting our stories from. It's not others, various news sites don't necessarily do that. So you definitely want to, if they don't, then you're gonna have to do a little more research to try and figure out where they got their story from. Hamid Turab, why the meteor showers do not hit the thousands of satellites orbiting the Earth. When you're lying on your back, watching the sky during a meteor shower, and then 1 minute you see a meteor go by, and then maybe a minute later, a couple of minutes later, you see another meteor somewhere else in the sky. Think about the volume of space that you're looking. You're looking up several hundred kilometers up into the Earth's atmosphere. You're looking from horizon to horizon. It's a gigantic part of space. And every meteor that you're seeing is about the size of a grain of sand that is vaporizing as it's hitting the atmosphere. And so you're seeing 1 grain of sand vaporized in an enormous volume of space. So space is really big. And satellites are very small compared to the giganticness of space. And so the collisions are very, very rare. Now, they must happen. But again, even so, the damage that's done to a spacecraft is not that bad because it's a grain of sand. So even though it's moving very quickly, it doesn't have a lot of mass, and so it doesn't do a lot of damage. And when, say, the space shuttle came back from its missions, you could see little chips in their windscreen from pieces of space junk and from various meteoroids that are crashing into it. And that's just sort of what happens. But it's not a catastrophic issue for any spacecraft out there. So don't worry about it. Dawn Sample. Instead of the complication of refueling James Webb, why not just clamp on a new module with its own thrusters? So what you're describing has actually been proposed as a way to give satellites more life. And in fact, I forget the name of the company. There have been companies that have built and I think even launched satellites that are designed to do exactly that. They're designed to give satellites, like say a geosynchronous communication satellites, which have run out of fuel, but they're still working fine in every other way. They still can transmit, they can still do all of they've got solar panels, everything's working. They just don't have fuel to maintain their position anymore. And so they launch this recovery satellite that flies up, clamps onto the satellite, and it has its own thrusters, fuel, reaction wheels, and can help give that satellite a longer lifespan. And it's a way to, like, instead of having to launch an entirely new satellite, you can just launch a much smaller, cheaper satellite to give your existing satellite a much longer lifespan. And this has been proposed, this has been practiced, and that's another way to go about it for sure. So when James Webb is about to run out of fuel, they launch a new satellite, and its job is to attach to that docking ring that's connected to James Webb, and then it'll have its own thrusters, its own fuel on board, and it will act as the way that James Webb will remain in its position for another decade. And then it detaches and floats away, and a new one shows up, and it connects, and it continues on with the job, and you could just keep doing that forever. So, and especially now as the costs of launching new spacecraft come down, I think we're going to see a lot more of this. So engineers are already on this, and I guess I need to do a video on that too. All right, well, that was fun. I got 2 more videos that I have to do now. Thanks everyone for asking the questions. I love them. And thanks in advance for all your feedback. Please let me know what are some books that you think I should read, and I will see all of you next week.